So, it has become quite fashionable to understand the structure of possible worlds as depicted by various branching models that give the space of possibility a tree-like structure emerging from some initial temporal segment that is necessary as well as unique. So to say that some object is a possible world is tantamount to asserting that it instantiates some specific initial time segment that it shares with all other objects of its class. One could claim that there exist distinct possible worlds, each of which shares this initial segment. Or one could deploy the language of various transition models to state that there is a possible world Wn that is identical to this initial segment, which then from there on transitions or branches off into some possible world Wm not identical to Wn. Now, to state that all possible worlds share some initial time segment would be to state that they are identical up to some time t. But maybe, for the sake of simplicity, we could understand this initial time segment not as having some duration, but as a state. Or we could at least set aside the issue of whether any of the posterior states differ across various possible worlds. So, let us just assume that there is some initial temporal state shared across all possible worlds, Wi, that exemplifies a set of properties Wp. Now, Wp then is a set of properties essential to all possible worlds. Yet, what subset of Wp, meaning which of the properties instantiated in Wi are essential properties of Wi? Now, the problem with the assumption that some initial world state shared across all possible worlds does have non-essential properties originates from the common distinction between essential and non-essential properties given by the definition of essentiality of properties in a modal context. 1. P is an essential property of some object X just in case X instantiates P in all possible worlds, whereas P is an accidental property of an object X just in case W has P, but there is a possible world in which X lacks P. Since every possible world instantiates Wi, then, according to 1, each property of Wi, namely the whole set Wp, is constituted only by essential properties. And yet, if the set of all possible worlds is constituted by distinct possible worlds that are not identical to each other, and yet all share Wi and therefore Wp, then there is an obvious problem. Since Wp is the causal origin of all possible world states posterior to itself, it cannot be, in fact, identical across distinct possible worlds, since there can obviously be extrinsic causal properties such as Wi is the cause of Wj. But since the subsequent states causally posterior to Wi differ across possible worlds, the properties of Wi, namely the set Wp, must differ across possible worlds too. But assuming that two objects are identical if and only if they share the same set of properties, then how could distinct non-identical possible worlds share some initial world state or segment? One consequence of this insight would be that if you accept modal branching as a plausible account, then you should therefore accept modal collapse, but that seems premature. Maybe to state that all possible worlds share some initial world state is to state that they all share the same type of initial state, and that is, that there exists some set of initial states that are identical in relevant respects, while accepting that they differ in respect to various properties. Now, one could certainly debate whether everything that can be predicated of a thing should count as a property of that thing. For example, whether or not some dog is such that there are infinitely many primes, and whether or not this should count as a property of it. But causal properties are not to be dismissed with comparable ease. So let's state that Wi instantiates a set of properties across all possible worlds, namely a proper subset we call Wp. And according to 1, the elements of We should count as the essential properties of Wi, which implies that there is a set of non-essential properties of Wi. But then, as we stated above, 1, as a definition of the essentiality of properties, is only adequate if we're willing to reject 2. If one accepts 2, however, one has to reject modal branching models altogether, if they are based on a common causal origin. Or one has to come up with a conception of the nature of properties that resolves the conflict between both conceptions. Yet, let us assume some causal origin across all possible worlds, and let us accept 1 and reject 2, then we can ask the question what kind of state Wi is. Suppose we accept 3, Wi is at least partially a physical state. Maybe the best way to argue for 3 is to argue that Wi is causally efficacious and therefore at least partially concrete, and then to accept 4, if some state of affairs W involves some concrete causally efficacious entity, then W is a physical state. Now, a theist will deny 4, and yet non-theists, especially naturalists, will probably accept 4. Whereas the theist who denies 4 will have little trouble accepting 3, for the sake of the argument alone. But then, If the naturalist accepts 4, he accepts that Wi is a physical state. Therefore, a theist may simply accept Wi as partially physical. In either case, this will suffice for the purposes of this argument, and then we can proceed with 5 for reductio. 5. For every possible world W, Wi is the initial world state. 6. Wi is a physical state. And 7. Wi has various non-essential properties that vary across distinct possible worlds. So, if one accepts that every physical state is causally efficacious, then by the same reasoning from extrinsic causal properties, given that one accepts modal branching models, or maybe better put causal indeterminism, one probably has to go even further and accept 8. Every physical state has non-essential properties. Now, this should be understood as a claim that the set of properties of some state W that is implied by the fact that it is physical is not exhaustive. Modally speaking, then, every physical state has a set of properties that vary across different possible worlds. Or maybe better put, every physical state has a set of properties that could possibly differ. So what does this tell us about Wi then? Now, if one accepts 8 and one accepts 5, namely the fact that every possible world shares the same initial state, then one has to accept that Wi has properties that differ across various possible worlds, in other words, properties that, respective to each possible world, could possibly be different. So if one accepts as much, one has done away with a central technical difficulty that accompanies all branching models. State identity across worlds then doesn't imply property identity. But then, sticking by the assumption of modal branching, the identity of the initial world state, one has probably moved closer to accepting 9. Every physical state instantiates non-essential intrinsic properties. The idea that underlies 9 is that every physical state is characterized by a set of quantifiable properties. In the ordinary understanding, this would be properties like a specific mass or charge or the velocity of some object. Whatever mathematical description sufficiently characterizes some physical state will not be complete without the inclusion of numerical values. Now, if certain physical properties are not sufficiently determined unless they are quantified, it seems that physicality implies a certain space of modal possibility. For suppose otherwise, that one is committed to identical initial world segments as well as some kind of physical metadeterminism that denies this modal space implied by the supposed quantifiability of physical reality, then it seems one ends up accepting modal collapse as well as strict physical determinism. Now, if Wi is a physical state, namely constituted by one or a composition of concrete causally efficacious objects, then it will have some content that is in some sense quantified. But now, if one accepts the idea that every physical state has non-essential intrinsic properties, then of course this holds true for Wi. So 10. Wi instantiates a set of essential intrinsic properties, We, and a set of non-essential intrinsic properties, Wa. And yet, if two physical states that differ with respect to their intrinsic properties are still identical, meaning that if Wi varies across different possible worlds with respect to its intrinsic properties, then it seems wildly implausible to maintain that modal branching models with such a supposedly identical initial world state as segments still have any sensible content. What would it mean to state that two physical objects are in fact identical and yet one weighs twice as much as the other? Not much. So it seems that if one wants to stick by some cross-world invariant initial world state, one has to accept a certain level of physical underdeterminism. In fact, Wi has to have some non-essential features that in some sense emerge from its essential features. There has to be some metaphysical bond between Wi's essential nature and its accidental properties, since, if not, you have a set of completely disconnected brute elements that determine Wi's nature, and yet Wi's nature is still supposedly characterized by some modal necessity, which seems absurd. So, 11. The set of Wi's non-essential properties, Wa, is partially determined by its essential properties, We. But by what kind of process should Wa originate from We? It seems it cannot be a causal process, since the idea of a state that determines its own nature by a causal process in which it becomes its own cause as well as its own effect, by causally affecting itself and therefore determining its own nature, seems hardly coherent. But the idea of physical emergence seems to either be a strict causal process, in the way that a vast amount of minor turbulences can lead to some major disturbance in some physical system, or physical emergence just captures the concept of constitution, such as wetness is an emergent property from a collection of water molecules. But in this case, wetness is as strongly determined by the nature of the physical composition as anything could be. It isn't like the wetness of the content of a bowl of water is somehow underdetermined by the water inside of it. So, 12. There cannot be a physical state that partially determines the set of its own non-essential properties, and therefore 13, Wy is not a physical state, which of course contradicts 6. This way, it seems that if the naturalist wants to maintain that there is some necessary initial world segment, he has to maintain that the initial world state is a non-physical state. A better strategy probably is to surrender the affirmation of any modal branching model that involves a modally necessary initial world segment. Maybe a better strategy would be to surrender the affirmation of any modal branching model that involves a modally necessary initial world segment.